Hi guys, welcome back to the shop. I'm James. Today's project is to X out a clock wheel. Like these. This is called X out, Xing out, or what's the other term? Crossing out. Crossing out. Both the same thing. So we've started with a blank here. And we've drilled a 1/4-inch hole in the middle after finding the center. And the reason for that is that most of this is just an assortment of old clock wheels, but you can see that the hole in the middle here is larger than 1/4 inch, because you don't just put this arbor through the wheel, you put it into a hub. Excuse me. That was somebody who wanted to loan me money.
James Lathe, village clockman.
I get about, ever since we came out in the Yellow Pages, I get about 10 to 12 robocalls a day wanting to loan me money or just everything you can think of, improve my website, whatever. And of course, that's the reason we have the answering machine. We don't answer any of those, we just ignore them. Anyway, the wheel here is larger than 1/4 inch. So you can see the hub here that's been pressed in and then marked in. So here's another one, same thing. The way you put that in there, if you don't want to solder it, you're not supposed to solder it, is you take a centering punch and you hit it right there, and you lay the brass over onto the wheel. And if you go around there, this guy didn't do it. This is pretty sloppy, but it takes about 6 or 8 hits around the wheel to yeah. Now here's another way of doing it. You can't even, this is the hub here, and you can't really see what's on the inside. You'd have to take this off, but it's basically the same thing. They're all basically the same thing. So that's the reason for the 1/4 inch hole. Here's another one. You see the way that's press fit in there and then swedged over. Okay. So you're always going to put a hub in here, so you don't need a hole smaller than 1/4 inch. In fact, it's probably going to be larger than that when you make the hub. Okay, so now we have to go bandsaw this out, and then we'll put it in the lathe and turn this down to the exact diameter that we want of the wheel, which is 2 inches. And of course we're starting out too large. This is 2 1/4. So we're starting out larger than we need, but that'll work out. I'll be right back after I bandsaw this out. There we are. You know what they say, it's always something. My smallest, thinnest bandsaw blade broke, so I had to cut this out pretty roughly, because it's a 1/2 inch bandsaw blade, the smallest one I have. I got to order some more, but this goes in here. I turned this tool out, and I gave it a nice big shoulder round here on both sides, and it gives it a lot more grip when you're turning it. And I also turned the inside. I don't know if you can, there you can see that. Turn the inside of that out, so only this part out here is touching. That gives it a lot more grip when when it's in the lathe. Come on. Okay, we're over to the lathe. This is going to be a little rough because we got a lot of rough corners, but it'll work. Whoop! Didn't tighten it enough. That vibration tends to pop things loose anyway. The belt is slipping a little bit. When you get out to this diameter, the belt slips. I gotta fix that. I'll be right back. See how close we are. Yeah, we're way oversized. Since this is just a demonstration, I think that's going to work anyways. So that's better. Good. Okay, this is a little oversized, but we're going to use that anyway. Save a little time. So we're off to the pantograph machine. Okay, this is, excuse my hand shaking. This is a Pries, three-dimensional, I think it's a 3D5, three-dimensional pantograph machine. Comes with a lot of different tools and all kinds of things. Extras. I was very lucky to get this. The last one of these on eBay was $1,200, and the letters, the fonts, were $400 a box. And I got this from an old gentleman in northern Maine who just wanted it to go to a good home. Okay, trying to do this. Here's the cutter. There it goes. This is where the cutter goes. That's a pointer in there now. This is a pointer in there now. And these bits are 3/16. This is a 3/16 collet in there now. So this is the part that where the cutter goes, that is driven by these belts, and it's a double pulley system. So this goes up around 8,000 RPM. Okay, this is the tracer. This is the tracer. You push this down when you're in a pattern like that, and that follows the pattern around. And then when you let go, it's spring-loaded, so it comes up. Okay, I'll put this back on the rack, and we'll set this up. I found that the best way to do this is with double-sided tape. You need your center bolt, but the double-sided tape keeps it from moving around a lot. So, where's my bolt? There it is. On the other side of this board, if you can see that, on the other side of this board is a T-nut, quarter 20 T-nut. So when this goes in, it's not just going into wood, it's going into a metal T-nut. There we go. Okay. Now, to set this up, let's see, I gotta raise this. There. This is a cutting spindle, and this goes up and down. It's in the up position right now. And when you do this, you turn that, it drops this about, it's really hard to see that. It drops the cutter down here about 3/32 seconds, a little over 1/16 of an inch. And that's how, and this is a micrometer up here at the top. This is a micrometer. This is really hard to do, get everything. This is a micrometer, and this is a lock. So once you get it set where you want it, so that it's only a 1/16 off, you can set your depth with this right here. And this is graduated in thousandths, and it goes up and down. So that's a secondary. That's your micro adjustment. This is your macro adjustment. Okay. Now to set this up, there's also a hand wheel underneath the table. And you can lower the table. Like that. This bolt I put in the lathe. You can see that. There you go. This bolt down here, right here, I put in the lathe and center drilled it. So I know that when I lower this, that is going to be dead center in the center of the wheel that we're cutting out. Okay, that's the way you center that. On this side, this is the, you saw the tracer. This one has a point on it. You put that in there, and lo and behold, it goes right in the very center. I'd set this up before. So that's how you set your distance between the work and the pattern. Now to set the ratio between this size and the size that you want to cut on there involves some math, and there's several ways to do it. I do it with an old-fashioned slide rule because I collect slide rules and I still like them. But another way to do it, I'm going to have to back this up so you can see both of these at the same time. Well, I guess you can. Yeah, there you go. Another way to do it, which is a lot quicker and a lot easier, is just put this tracer in like that. Put this on the outside of the thing, and then set your pointer where you want it, and that is just about right. And that's fine. Okay? Now we take the cutter out, or we take the pointer out, which is only in there finger tight right now. You take the pointer out, there's the pointer, and you put in the cutter. And another thing you might note, the diameter of this tracer must be the same diameter as the cutter. Otherwise, your dimensions will be off. So those two right there are exactly the same. And I have more than one tracer. If I change cutter diameter, I have to change the tracer. But this is just a piece of drill rod that I made. And this is only held on with an Allen, and the spring fits anything. So I have probably 6 different tips like this, like that. Okay, now let me put the cutter in. When I got this machine, there's 2 holes up underneath here, and that takes a pin wrench, and I didn't like that at all because I found it very hard to do. So I took the whole spindle out, took this out, and milled off flats on both sides of the spindle, and do it with wrenches, and I just find out it makes it a lot tighter. The whole thing is just a lot better situation. So, okay, now we got to run this down again. So we're just a little bit above that right there, and you can see that when I move that, that goes down. It's probably going to go down a little more. As long as the cutter goes all the way through the brass when it's in the down position, that's good right there. Okay. I did not explain, I just remembered that, how you set up the arms. Let me take the camera right off of here. I think I'm going to have to do a lot of editing on this one. Okay, there's 3 points that you have to pay attention to. There's this one, we'll call that A, and there's the opposite one over here, we'll call that B, and there's this one here, we'll call that C. And these must be set in exactly the same position. Right now, there. You can see there's a witness mark on that. And this is set on 2, 1, 2, 3. The third mark up. The third mark up from 2. So if we go over here, we're the third mark up from 2. And right here, on C, we're the third mark up from 2. Okay. Those absolutely must be set exactly the same, all 3. Otherwise you'll get an oval or some odd shape other than a circle. Here we go. Oh, one other thing. This machine, this company, Pries, P-R-I-E-S, went out of business in '74. There are other pantographs out there. The really big one is called Gorton, G-O-R-T-O-N, and that is a much bigger machine and heavy-duty machine. And those are quite available. You can find those. There's actually a Gorton Yahoo site. If you go into Yahoo groups and put in Gorton Pantograph, you'll find that. And they come up fairly often. They can run a couple grand for a good Gorton, but you might get lucky and get one cheaper. So, but this is a Pries, and they've been out of business a long time, so there's no support, there's no parts available or anything. So if you find a Pries, make sure everything you want and need is with the machine when you buy it. Okay, it's a two-handed job. This hand's holding the tracer, and this hand's going to lower the, let's go over here. This hand's going to lower the cutter. 2 passes. Okay, that is quite hot. So you don't want to touch this because it's hot after all that. So there's the first one. It's got a lot of burrs on it. And when you file it, there's special files that you can buy called crossing out files. And you can file these radiuses here on the corners to right into to a square, to a right angle corner if you want to. Depends on the clock. Sometimes it's for a really special job I do that. Otherwise, I just leave them the way they are. Take all the burrs off and then burnish, file these and then burnish them. So let's cut another one so you can at least see what that's going to look like. Okay. I'm down all the way now. Whoop. Popped up. I have to keep my hand on that. When you're doing this, pay most attention to the pattern. Because if the tracer slips out of the pattern when the cutter is down, you're going to be in trouble. You're going to make a mess. So you want to watch the pattern mostly, and don't pay much attention to the cutter. It's going to go where you want it to go. See, I was all the way down that time, and I did that all in one cut. So you can begin to see what the wheel's going to look like. Now this is a sample, remember, so this is not the real thing, but this is not near wide enough here. By the time you cut the teeth, you're not going to have anything left there. So my ratio was a little off, but I just wanted you to see the basic process of how it's done. Let's cut one more. what I just did what I said not to do. I slipped. No, I didn't really ruin it though. I don't think I did. See if we can straighten that up a little bit, maybe. No, I messed that one up. But you can see the process. I would cut the teeth first before I cut the wheel out, because you need that extra material in here as support for cutting the teeth. And oh, the patterns. These patterns are just made out of lucite that you can buy at the hardware store, and you lay them out. There's two layers here. There's a thickness under. There's a solid piece under here, and another piece epoxy to the top of it. And the important thing on these patterns is. Sorry guys at that rather abrupt ending. I'm still learning this camera thing. I don't know what happened at the end there, but I lost the last minute of it, but you didn't miss anything. I just wanted to say thank you very much for watching. I think our next project will be making a spiral gong for an English skeleton clock. It's sort of a interesting project made out of piano wire. So I hope you come back and watch. Thank you very much for subscribing. I'm over 450 subscribers now, I think, which is amazing considering how shortly we've been doing this. But thank you very much for watching. Please subscribe and like, and please comment. I try to answer all the comments. So I'll see you soon. Bye.